We are doing, or we're starting bonding and types of bonds. And so for this unit, something that you're really going to need, like I've said a couple times, is a periodic table, because we're going to learn about the 3 different types of compounds as well as how to name them. So for today, we're going to start with just a basic intro to all 3 types of compounds, just to kind of give you a little background before we dive in to learning about each one more specifically. So let's get started. All right, so first things first, guys, there are 3 types of compounds, like I just said. All right, there's ionic, covalent, and metallic. So we're going to start by talking about ionic bonds. And an ionic bond is formed between a metal. I'm going to zoom in a little more so my handwriting is better. Let's try this again. So an ionic bond is formed between a metal and a nonmetal. So, real quick reminder, I'm going to move my picture to the other side, of where metals and nonmetals are found. So if I look at my periodic table, you guys should know there's that nice zigzag line on our periodic table. See it right there? The nice bold zigzag line. All right, so I've got my zigzag line. And all of my metals are found to the left of my zigzag line, and my nonmetals are on the right of that zigzag line. So, so we'll have one element from the left side of our periodic table and one element from the right side of our periodic table in an ionic compound. And in these ionic compounds, electrons are transferred. So what happens is our metal transfers its electrons to our nonmetal. All right, so electrons are transferred, they're completely given up, and our metal gives its electrons to our nonmetal. So I'm going to show you guys what this looks like with an example, and we are going to use NaCl as our example. NaCl. NaCl is also known as sodium chloride, which is table salt. All right, so in NaCl, I have sodium, and sodium is Na. All right, that's its symbol on the periodic table, and I'm going to draw the electron dot configuration for Na. Drawing the electron dot configuration is really easy. It's just basically putting how many valence electrons are around our element as dots. So, for example, if I have sodium, sodium is in my first group, so sodium has 1 valence electron. So sodium is going to have 1 dot around it. And then I also will have chlorine. And then chlorine is in our 17th group, so chlorine has 7 valence electrons. So I'm going to put 7 dots around chlorine. The only thing about like dot notation that they're called Lewis structures, Lewis dot notation, is that you have to put 1 dot around each side before you go back and pair up. All right, so as you can see, guys, everybody's goal is really to get to 8 valence electrons. Well, sodium has 1 and chlorine has 7. So what's going to happen is sodium is going to donate that 1 electron to chlorine, and when it does, then what we form is sodium, and it's lost 1 electron, so it now has a positive charge. Now, when sodium loses 1 electron, all right, it now has 10 electrons, so it would have the same electron configuration as neon, which is a noble gas, 8 valence electrons, very stable. All right, and then chlorine, similar thing. So chlorine then had 7 valence electrons. It gained 1 of sodium's, so now it has 8, and chlorine has that -1 charge. All right, and so chlorine, when it gains 1 electron, then has the same configuration as argon, noble gas, stable, so they're happy. And then sodium has that positive charge, chlorine has that negative charge, positives and negatives attract, so therefore they basically form a bond based on that attraction of the positive and negative charges, and that is an ionic bond. And it's formed by a Coulombic attraction, which I kind of talked about Coulomb's law a little bit last unit. So yes, that Coulombic attraction. So that is an ionic bond. Metal and nonmetal, electrons are transferred, and the bond is formed by the attraction of the positive and negative charges. Okay, now then let's talk about covalent. So covalent is formed between two or more nonmetals. So if I'm looking at covalent compounds, I am only looking at the compounds that are to the right of my zigzag line over here. So only compounds that are to the right of my zigzag line. All right, so two or more nonmetals. And in covalent bonding, electrons are shared. So basically the reason they're shared is that when they're transferred, it's because there's a really high difference in their electronegativity. And so one of them is really electronegative while the other isn't. And so the one that's really electronegative completely steals the electron. Now then, in covalent compounds, the difference between their electronegativity isn't great enough that one of them can steal it. So instead of stealing it, they're just going to share it. It's going to be somewhere in the middle. All right, so I'm going to draw a picture of a covalent compound for you guys so you can kind of see what it looks like. So the one I'm going to draw is going to be ammonia, which is NH3. You guys should know ammonia. It's what's in Windex. The active ingredient? Yeah, one of the active ingredients in Windex. So ammonia, it's nitrogen trihydride is another way of naming it. Okay, so nitrogen has 5 valence electrons. So nitrogen looks like this with its 5 valence electrons. Remember in our electron dot notation, you have to put 1 around each side before partnering up. So I only have 1 partnership here. All right, and then hydrogen only has 1 valence electron. So hydrogen is going to come in with its 1 valence electron and basically share that 1 valence electron with some of nitrogen's electrons and thus form a covalent bond where our electrons are shared. So there's our bond right there between our shared electrons. And that's a covalent bond. So electrons are shared. And the electrons should hang out kind of with nitrogen for some of the time and with hydrogen for some of the time. We can actually check and see their like how many valence electrons they have now. So if I look at my hydrogen, all right, this hydrogen right here, it's sharing those 2 electrons, so that hydrogen has 2 electrons. Now hydrogen is on our first energy level, so hydrogen is full or stable with only 2 electrons. Okay, same thing for all of our hydrogens. Since they're sharing those electrons, they all have those 2 electrons, so they're stable, they're full. They have the full valence shell. Then our nitrogen also is sharing those electrons too, so it ends up with 2, 4, 6, 8 valence electrons around its outer shell. 8 valence electrons is noble gas configuration, so it's going to be stable and full as well. So that's why covalent bonding works, because basically the whole premise of covalent bonding is that they share electrons so that everybody gets a full valence shell of electrons. Okay? And our last type of bonding that we are going to talk about is metallic bonding. And in metallic bonding, it is, get the right color, I'm going to write it kind of below, 2 or more metals. 2 or more metals. And metallic bonding is kind of interesting because it's a little different than our other ones. But in metallic bonding, our valence electrons are donated to form, and this is going to be our big key for metallic bonding, they form the sea of electrons. The sea of electrons. And so this actually is what gives metals a lot of their properties. So they're shiny because of the sea of electrons. They're malleable and ductile because they have the sea of electrons. So the sea of electrons is really a big key. So a lot of times if you see a question about metallic bonding, really think, like, first word that should pop into your mind with metallic bonding is sea of electrons. And so all the electrons are donated, and we have kind of floating positive cations in this sea of electrons. And so it would kind of look, this isn't going to be the best picture ever, but just to give you a general idea, kind of look like this. So we would have our positive metal cation, positive metal like that have donated their electrons. And then we would have that sea of electrons around it. And I'm just going to draw my electrons as little negatives of the electrons that they have donated. And so because they have this sea of electrons, they're able to conduct electricity. Electricity is a flow of electrons, and so you have to have charges for them to be able to pass through. So because of that, they can conduct electricity. They are malleable because the atoms are basically able to like flow and slide past each other in that sea of electrons. It just leads to a lot of different properties in those atoms. Okay, so now we're going to kind of sum up in this table our types of bonding, as well as talk about some properties that are unique to each type of bonding as well. All right, so first type of bonding is ionic bonds. And once again, guys, in ionic bonds, electrons are transferred. This happens between metals and nonmetals. And we will talk, there are some special cases as well. So they can also form between a metal and a polyatomic ion and a polyatomic ion, and a polyatomic ion and a nonmetal. So you guys should receive today a polyatomic ion sheet, or it'll be posted on Canvas. And so guys, we would highly suggest, we know you can use your notes this year, but we'd highly suggest starting to work towards memorizing those, as it will make your life much easier in the long run. So you'll get a polyatomic ion sheet and you'll kind of start to learn what those are. All right, so it happens between metals and nonmetals. Some examples are like sodium chloride, NaCl, that's table salt. Another one that you guys might be familiar with is magnesium sulfate, MgSO4. That is Epsom salt. Those are like two big ones that you would see outside of life, but a lot of substances are ionic compounds beyond just those. All right, then we have covalent, and in covalent, electrons are shared. And we'll talk about this much more in a later unit, but they can be shared in two different ways. They can be nonpolar covalent, and this is when they are shared evenly. So in our covalent compounds, since electrons are shared, it's kind of like a tug of war match. And so in nonpolar covalent, this is a tug of war match in which they're very evenly matched, and nobody's going to be able to like pull the electron more to its side because it's a very even matching. And then in polar covalent, it's an uneven sharing. So one electron is going to have it way more. So this would be like someone really strong versus someone really, really weak. The strong person is going to have the electron more often. So they're shared unevenly in polar covalent. Covalent compounds are formed between two or more nonmetals. And I'm going to give you an example of a nonpolar, a polar, and in polyatomic ions. So a nonpolar covalent compound is CH4. And CH4 is known as methane. It's an organic compound, which we will also talk about this unit. And then polar, probably the most famous polar compound, is water, H2O. So that's water. Or dihydrogen monoxide is another one. Another one is also the NH3 that we talked about earlier. That is ammonia. And then covalent compounds are also found in our polyatomic ions. So there's lots of different polyatomic ions. There's nitrate, which is NO3 -1, carbonate, CO3 -2, cyanide, Cn -1. Lots of different polyatomic ions. And then last, but certainly not least, we have metallic. And in metallic, they form that sea of electrons. And it's formed between two or more metals. All right, some examples of this is like any kind of metal. Silver. Oops, I don't know what happened there. Try that again. Silver, platinum, I don't know, also in alloys, so like brass, bronze, steel. This is the type of bonding that will occur. Okay, now we're going to go through their physical properties. And this is just kind of like a page break here, so nothing is going to fill in there. But let's talk about them. So melting point and boiling point. So ionic compounds are going to have really high melting and boiling points. They're going to be really high. 800 degrees Celsius is sodium chloride's melting point, which is extremely hot, guys. That is close to 1500 degrees Fahrenheit if we were converting it. All right, so they have a really high melting and boiling points. Typically, ionic compounds are going to be solids. There's a few ionic compounds that are liquids, but for the most part, ionic compounds are only going to be solids. All right. Ionic compounds are soluble in water. Not all of them are. There are some exceptions and times when ionic compounds are not soluble in water, but for the most part, ionic compounds are soluble in water. And conductivity is just, so solubility, yes, I should probably define those. Solubility is ability to dissolve. And specifically when we talk about we typically talk about ability to dissolve in water. And then conductivity would be ability to conduct electricity. All right. So ionic compounds can conduct electricity, but not when they're solids. They can only conduct when they are dissolved in water. All right. Now then, next we have our covalent compounds. Covalent compounds are going to have really low melting and boiling points. They come in all three states. So you'll see solids, liquids, and gases, but they are much more common. It's much more common for them to be liquids and gases versus ionic compounds. And most of the time they're solids with very low melting points, like wax. Like wax is a solid, but it melts at a very low melting point. They are insoluble in water. They do not dissolve, and they do not conduct electricity. I guess I should say, let me try that again. So for covalent compounds, polar compounds will dissolve in water, while nonpolar will not dissolve in water. So polar compounds will dissolve in water, nonpolar compounds will not dissolve in water. So for example, like sugar is a polar compound. Sugar dissolves in water, and it is covalent. Oil, also a covalent compound, but it does not dissolve in water. So those are kind of some examples. And covalent compounds do not conduct electricity. Last but certainly not least, let's talk about metallic bonding. So metallic bonds also have, metals also have really high melting and boiling points. It takes a lot of energy to get them up and to melt or boil them. They are typically, metals are going to be solids at room temperature. There's one exception to that, and that is mercury, which is Hg. And mercury is a liquid at room temperature. Some of them melt at like very low melting points, like gallium will actually melt just in your hand at like body temperature. I don't know, whatever you call that. But yeah, like some of them will melt at really low melting points, but they're all solids except for mercury. Metals are insoluble in water, and they do conduct electricity. Okay, so that is basics of bonding. Hopefully this video was helpful. You guys have a lab today over this as well, so be sure to use this to help you answer your lab questions, especially as we're getting into properties and learning about the different properties of ionic, covalent, and metallic. All right, guys, have a great day. Bye.